All right, welcome. This is properties of squares and trapezoids. Let's get started. First of all, properties of squares. Well, property of squares is pretty cool. A square has everything. So these are all of the properties of a parallelogram right here. So that's our parallelogram right there. So it has all those properties. It has all the properties of a rectangle, which are these guys right here, which I just cut off early for some reason, my bad. And it has all the properties of a rhombus, which are these guys right here. So square is like the do-it-all, be-it-all cool guy. And so what makes it really easy is that we've kind of already talked a lot about it. So I'm going to kind of give you a demonstration of that on our first two questions. So first two questions is, if all this is true, it's going to make my life pretty easy. So this is 2x plus 13, and WU is 8x minus 41. Well, diagonals are congruent, and they bisect one another, so all you have to do is set those two equal to each other. So 2x plus 13 equals 8x minus 41. And when we set those equal to each other, we end up with x equals 9. But then it says find VT. Well, that's actually not too bad, because all I have to do is plug it back into one of these. It doesn't matter which one. I'm going to plug it back into 2x plus 13. So that's 2 times 9 plus 13. That's going to give me 31. But 31 isn't the full length. The full length is going to be twice that. And the diagonals, not only do they bisect, but the diagonals are also congruent. So if this whole thing right here, we'll call it blue right here, VT, it's going to be 31 plus 31, where VT equals 62. All right, in a square, solve for hex. So this one seems really hard, but remember, it has 4 right angles, so these are 90s. Okay, all these are 90s, and the diagonals bisect the opposite angle, so these are congruent. Well, if you bisect a 90 in half, that's a 45. So it's always a 45. So you just basically get 7x plus 3 equals 45. And then you just solve from there. You subtract and divide, x equals 6. And that is it. Pretty simple, really. Okay? Next, coordinate geometry, we're going to do that in class, because why not? That sounds too fun. But let's talk about traps, because you guys need good traps. If you don't have good traps, you're just looking really small. And I'm talking about working out traps. But in real life, traps, we have trapezoids. So here we go. So we have non-isosceles trapezoids, and we have isosceles. We're going to look at both. So non-isosceles means these two sides are not congruent. Isosceles means these two sides are congruent. So like really the key here, when I say isosceles, I'm referring to these being equal versus these two are not. So if it's not, we only have one pair of opposite sides are parallel, which we see right here, boom, and consecutive angles between parallel lines are supplementary. So basically, it's saying like angle 1 and angle 2 here are going to add to 180, okay? And also these ones as well. Okay, so we would say angle 1 plus angle 2 equals 180, and then we would say 3 and 4 equal 180. If it's an isosceles, which we actually see way more common, we have a non-parallel legs are congruent, so that's there. Diagonals are congruent, so this diagonal is equal to that diagonal. Base angles are congruent, so this whole angle is equal to that angle, and these angles are equal to each other, and opposite angles are supplementary, so these add to 180 as well. So a lot more rules going on. So when we apply all those rules, it gets a little messy, and I can't possibly do all of these, so we're just going to do a quick setup on all of these. This is isosceles, base angles are congruent, so you just set them equal to each other. So again, I'm not going to do every single problem here. We're going to see a lot of these different examples. When I solve for this, I get x equals 13. Unfortunately, it asked me for all the other angles. Well, we know that our opposite angles are supplementary, as well as these angles are supplementary. So if I can find this angle, I can find the other angles pretty easily. So I do 2 times 13 plus 27, I get 53. So D and C are 53. And then the other two angles have to be supplementary to that, which makes them 127, because those add to 180. And then in the side lengths here, it says in the isosceles trapezoid, MP, which is this side, and NO is this side. Well, we can find those easily. Those are going to be congruent to each other, so we just set those equal to each other. So 16x minus 13 equals 9x plus 8. Well, that ends up being x equals 3. And then it says Pn, which is this and this MO. Well, diagonals are also congruent, so we just set those equal to each other. And we get y equals 8. Last but not least, we have the trapezoid, or sorry, mid-segment of a trapezoid. So if EF is the mid-segment of trapezoid, then we know that AB is parallel to DC, which is also parallel to EF. So these are all parallel, so we can put a little parallel mark there. And then we also have this really unique relationship where EF is actually equal to AB plus DC divided by 2, also known as just the average. Okay, so I'm going to show you that in this demonstration right here. So AB and DC are my two bases, okay, the top and the bottom. So if I add those two together, 2x plus 11 plus 6x minus 1, if I add those two together and divide it by 2, right, that's my average, that should equal my mid-segment, which is 25. Okay, and then to solve this, we're going to multiply a 2 out from both sides. Switch colors here. So I get 50 equals, and then I'm going to combine like terms, 8x plus 10. Subtract the 10, I get 40 equals 8x, and then x equals 5. And then it says find kj, so I just got to plug it back in. So 6 times 5 minus 1, and that's going to give me kj is equal to 29. Similar thing you're going to do for the other one. You're just going to add the top and the bottom, divide it by 2, and set it equal to 8x minus 3. All right, guys, thank you very much. We'll talk more next time.